Yeah. So today we'll start about the pack in UVM. So this is nothing but a pack method, that is a built-in UVM function. Easy to serialize an object, that is converts content of object into packed bit stream. Okay. Packed and unpack is there. Okay. This is the syntax for packed sequence. Function int. Okay. It will return an int function. Pack UVM underscore packer equal to null. Okay. So that means it will return number of bits in packed. Okay. That's why it will return the int function. Okay, so we'll see one program related to pack. So just pack clone is completed. Okay, UVM phases we'll see. UVM phases I did. Okay, so if you see the pack, okay, this is by using macros. Okay, this program is by using macros. Uh, so if you see, this is my header files. Take include UVM macros.sph and import UVM pack. So first what I am doing, so I'm creating means class my transaction extends UVM underscore sequence underscore item. Okay. So this I'm extending this UVM underscore sequence underscore item into my transaction, and I'm creating the properties rand bit 7 down to 0 address, rand bit 15 down to 0 data, and these are nothing but my built-in macros. That means tick UVM object utils begin my transaction. Okay, so I need to create one ID, no. So for creating my ID, I need to use UVM factory. In that, I will use this macro, that is tick UVM object util begin my transaction. And for the address and data, I'm creating this. I'm using macro only. Tick UVM field int address UVM all on. Okay, so this is nothing but my flag. It will be applicable for all address. Okay. Similarly, it will be tick UVM field underscore int data UVM underscore all on. This will be applicable to data also. Okay. Again, this is end. Okay. And next, what I am doing, function new string name equal to my transaction and super dot new name and end function. Okay. I am returning a function and end class. Okay. And in the TB, what I am doing means I am creating two handles. Those are nothing but tx1 and tx2. So my underscore transaction tx1 and tx2, and I'm creating the property bit packed bits. Okay, and this one I'm using, and int unsigned n bits. Okay, so I need to create the instances, no. So like this, tx1 equal to, how I am creating the instances means tx1 equal to my underscore transaction. So this operator, okay, uh, type ID create tx1, okay, and tx2 equal to my transaction, type ID create tx2, okay. So here what I am doing means I am randomizing, okay. So do you understand? Do you remember or not? We have randomization concept in the SV, okay. So that tx1 dot randomize function I am calling, and I am displaying, okay, and declaring original tx1 is address, and displaying in terms of hexadecimal data. Also I am displaying in terms of hexadecimal tx1 dot address and tx1 dot data. Okay, and next what I am doing, I am writing for packet transaction field into bit array. So how I am writing? I am writing n bits equal to tx1 dot pack underscore bits. Okay. After that, I am displaying this packet bits. Okay, n bit percentage d and n bits. For each I am using packet bits of e begin dollar right, percentage b packet bits end. Okay, dollar display. Okay, this is nothing but packed. Okay, so packed and unpacked means what? Normally tx2. So I'm unpack the bits array into second transition. tx2 dot unpacked packed underscore bits, and I'm displaying these packets. Okay, dollar display after unpack is nothing but address h data h and tx2 dot address tx2 dot data. So I'm finishing. Okay. So this I will see in the EDA playground how I am getting. So this is the example related to the pack and unpack. So copy this, and I created. Okay, see here. So when I'm writing the program, so in the test bench, so you need to create. This is anyway SystemVerilog and UVM 1.2. and tools and simulators. I need to select Aldec Rivera. Okay. Just to copy this, this paste this. Okay. Run this. I want to see the logs. See here. Here original transaction. Okay. Before unpack, I'm getting original TX1. Okay. Where I displayed. See here, dollar display before unpack. Okay, before packing, original TX1 equal to what normally it is getting. Okay, randomizing. I call the function randomize. No, so I call the randomize means what randomly it is generating the values. Okay, so randomly, so address equal to what 46 and data equal to 1CAF. Okay, after that, so see here, this is original address equal to 46 and data equal to 1CAF. Okay, so packed n bits equal to what? So I need to display, no, dollar display packed bits n bits equal to what percentage d. Okay, so this one it is displaying comma n bits. So if you see here, how many bits are there? Where here you see 7 down to 0. 7 down to 0 means how many bits? 8 bits. And 15 down to 0. So here how many bits? 16 bits. 16 plus 8, how many? You will get 24. Okay. So packed bits, n bits equal to what? How many? 24. Okay. And packed. So packed means what? So it will be packed into what? In terms of like binary bits, it will display. See here. Packed bytes, it is converting into binary and it is displaying. See here, suppose 46 is there. 46 is displayed like 0, 1, 0, 0. 6 is 0, 1, 1, 0. And 1 is 0, 0, 1, 0, 1. C is 1, 1, 0, 0. And E is 1, 0, 1, 0. And 5 is 0, 1, 0, 1. So in terms of whatever the value is there, it is displaying in terms of binary. Okay, that is nothing but packed. Okay, and after that, what I am doing? I am doing unpacked. Unpacked means what? Normally it is displaying. Again, it is unpacking the my after unpack. Okay, so dollar display after unpack tx2. Tx2 equal to what? Address that is equal to 46 and data equal to 1CAF. Okay, so like this I can do the packed and unpacked. Okay, so this is about packed and unpacked. Uh, this is by using macros. Okay, this is by using macros. So I can do the this packed operation. I can write the program by using two methods. One is by what is this? One is by using macros, or other by using that is do underscore copy. That is nothing but a virtual method. Okay, so do underscore copy. So this is the method in do underscore copy. So here if you see. So do underscore copy, same thing. I'm including the header files. Okay, I'm extending my class, my transaction extends UVM underscore sequence underscore item, rand bit 7 down to 0 address, rand bit 15 down to 0 data. So we need to register the class now. So how we are registering means register the class into the UVM factory. I need to use that macro. That is nothing but tick UVM underscore object underscore utils my transaction. Okay. So that means so one ID will be created and in registering my class into that UVM underscore factory. Okay. After that, I am creating the function new string name equal to my transaction super dot new name and end function. Okay, and next what I am doing, manually I'm implementing the do underscore pack method. So how I can do virtual function void do underscore pack underscore pack packer. Okay, I'm calling this subclass super dot do underscore pack equal to packer. Okay, next use the packer to pack the field in specified order. So that means how I can specify order means here. So that means packer dot pack field is this the data 16. Data I'm giving to 16 and address I'm giving to 8. Okay. So previously I used randomization. Here I'm giving some values to the data and address. Okay. And so manually implement do pack. So manually I can do the do pack by using virtual function void do underscore pack UVM underscore packer. Okay. and I'm calling this subclass, okay, superclass, super dot do underscore unpack packer, okay. And next, unpack the fields in reverse order also. I can unpack the fields in reverse order, okay, by using this dot address equal to packer unpack field int 8, and this dot data packer unfilled unpack field int 16, okay, end function and end class. So next what I'm doing, I'm writing the test bench, okay, module tb. So my transaction, I'm creating the handle, and I'm initializing the bits, okay, bit packed underscore bit, and int unsigned n bit, and I'm creating the instances by using this tx1 equal to my underscore transaction scope resolution operator type id and scope resolution operator create tx1, and similarly tx2 equal to, here I'm randomizing, okay, I'm randomizing, and after that I'm packing. Okay. So that means n bits equal to tx1 pack underscore bits. Okay. I'm displaying that values. Okay. And after that I'm using for each. Okay. Here this is same only. So same for using pack and unpack, the same programs I wrote. Okay. But here which method I'm using means I'm using do underscore copy. Okay. That is the only difference. Previously I used the macros. Here I'm using do underscore copy. Okay. So this one I'm executing. So when I execute, just copy this and just paste in the in this EDA playground. Just run this. Yeah, see here. Yeah, I got no. See here. Original TX1. Okay, before packing, what is my address? Address is 46. No. So what is randomization? It is doing randomization means I got 46, and data equal to what? Data equal to 1C if I got. So packed bits equal to how many? 24 only, no? So here in this properties, what bits I gave in the TB? In the TB, what bits I gave? This is a do underscore pack, do underscore pack. 7 down to 0 and 15 down to 0. Okay. 7 down to 0, 8 plus 16, 24 only, no? So that is giving. So packed bits, n bits equal to 24. And whatever these values are there, packed means what? It is indicating in terms of binary. Okay. Unpack means normally it is indicating. Okay. Unpack tx2 equal to, again it is randomized. You are getting different values. Okay. Address equal to 1C and data equal to A546, like this you are it is showing. Okay. So this is about the packed and unpacked, and next we'll go with an important topic, that is nothing but UVM phases. Okay. So this is about packed and unpacked. So this is do pack. Do pack is a virtual method that you override in UVM object UVM underscore sequence underscore item. Okay. There are two level systems, pack and do underscore pack. Okay. Pack is standardized, do underscore pack is customizable. Okay. Um, so common packing function inside the do underscore pack is nothing but we use we UVM underscore packer. Okay. That we'll use. Okay. These are different types of methods. Okay. Pack field value comma size. Okay. This packs the integer bit or field. Pack underscore object. This packs the nested UVM objects. Pack underscore string. This will packs the string. Pack underscore underscore number. This pack the real or double, like that. Okay. So this is about the, so with this we completed the UVM built-in functions. Okay. We completed the UVM built-in functions. Next we'll come with UVM phases. Okay. What are these UVM phases? We'll see. Okay. One second. Yeah. UVM phases. No. Yeah, one second. I will open this board. It will take time, I think. So one second. UVM phases. Yeah. I will open this only. UVM phases we'll see. Okay. So what are these UVM phases? Okay. First, what are these UVM phases means? First, each testbench component is derived from the UVM underscore component that has predefined phases. They are represented as callback methods. Okay. So callback method means what you can call back top-down approach or bottom approach. Okay. So hence user may implement this callback approach. Okay. So here suppose like so UVM phases if you take uh, so so in SV, so that means like UVM phases. Okay, I'm opening this. One second. So so this is UVM phases. UVM phases. Yeah. So that means in SV, I think you already studied in SV that you have build function and that is build function. This will create all the instances. Okay, it will create all the instances. This will be done in run phase. Okay, this will be done in run phase. Okay, so that this will be done in run phase. So that means here in the in the SV, what you have. So when you study about the test bench in the UVM, first you have test, and next you have what environment. Next you have uh, uh, environment. You have generator. Okay, and next you have driver. Okay, next you have driver, and next monitor, and you have scoreboard, and you have reference model. Okay, so that means these will be callback. Okay, how they are callbacking. So these all will be callback by using a method called randomization. By using a method called randomization. Okay, randomization also we discussed. Okay, in randomization also you have two types. One is pre-randomize, pre-randomize, and next one is post-randomize. Pre-randomize and post-randomize. Okay, pre-randomize and post-randomize. Okay, so that means whenever you are calling this randomize, there is a code that inside the code there is a logic function is there. So that means these are nothing but what pre-randomize and post-randomize means. These are nothing but some functions. Okay, so when you call a randomize function, okay, when you call a randomize function, it will call these two pre-randomize and post-randomize, and that this is nothing but one function. It will execute. Okay, it will execute. Okay, so like that, suppose like if you want to do for monitor, so that if you consider UVM. Okay, so when you do for monitor, so how we will do? So that means this case is nothing but this case is with respect to what SystemVerilog. But what is the case with respect to UVM? Okay, so with respect to UVM, suppose if you want to call monitor, first what you need to do? You need to go into UVM underscore object. Okay, after that you need to go to UVM uh, UVM underscore component. Okay, it will go to UVM underscore component. Okay, component. Okay, so that means here you have callback methods. You have callback methods that callback methods are there. So these are nothing but these callbacks we call as UVM phases. UVM phases. Okay, so that means UVM phases are nothing but these are functions only. Okay, these are functions only. You have like nine phases are there. Okay, so why we are using this functions or phases? Why we are using these functions or phases? Functions or phases in order to synchronize the components. Okay, so we are using these functions or phases in order to synchronize the different components. Okay, you have different components in the test bench. So in order to synchronize, we are using this phases or functions. Okay, So first you have what built-in phases. First we will see built phase. Okay, built phase. Okay, this is what this is callback method, callback method, and this is nothing but my function. This is one function. Okay, so where it is declared, this is declared inside the UVM component. Okay, this is declared inside the UVM component. Okay, UVM component. Okay, so why this where these build phases are used? This is used for creating the test benches. These are used for creating the test benches, test bench components, test bench components. Okay, so test bench components. So see here. So if you see, each component cannot. So that means each test bench component is derived from each component UVM underscore component. Okay. So that has a predefined phases. They are represented as what callback methods. Okay. Those are represented by callback method. Hence, user may implement these callback methods. Okay. Each component cannot move to next phase unless current phase execution is completed for all components. Okay. This provide proper synchronization between all components. Okay. So that means here if you consider, suppose in SV, suppose if you take in SV, so SV what we have seen, suppose in SV, if you consider in SV, so if you take in SV, you have test, and you have environment, and you have driver, test, environment, and driver. But in UVM, okay, so that means here in U, this is in SV, in UVM, you have test, and next you have environment, and after that there is an agent, and under the agent you have driver. Okay, driver means normally you have sequencer. Okay, driver is nothing but you have a sequencer is also called, so in UVM we call as a sequencer, but in SV we call as a driver. Okay, sequencer and monitor. Okay, driver and monitor. Okay, so that means here, so there is like so there is a hierarchy, like how the driver means a driver is created. So there is some object, so driver is one object. So this will point to this agent. Agent is also one object. This will point to this environment. Okay. And the environment is a pointer that will point to test. Okay. So like that it will come. Okay. This is nothing but it's like a phases. Okay. Built-in phases. These are phases easy to create the instances. Suppose like let us take first. So like it will be executed in sequence. Suppose test is test is executed. First test is executed. Okay. After executing this test, again next environment will be executed. Okay. After that, agent will be executed. So after executing this test, then environment will be executed. After executing this, agent will be executed. It's like what? It's like a callback method. It's like a callback method. Okay, callback method, and this is a virtual method. This is a virtual method. So that means it is happening automatically. Okay. So nowhere we are calling this function. This is happening automatically, and this is nothing but top to bottom approach. Top to bottom approach. Okay. Top to bottom approach. Okay. So here if you see, so so that means each component cannot move into next phase unless current phase execution is completed all components. So that means we already seen when test is completed, then it will go, then only it will go to the environment. When environment is completed, then it will go to the agent. Okay, this provides the synchronization between the components. Okay, so UVM phases are executed in a certain order. I told all are in virtual methods. These are nothing but virtual methods. Okay, so virtually this will be executed. Few phases that consume simulation time for execution are implemented as tasks, or other phases do not consume any simulation time or implemented function. Okay, so like so that means main categories of UVM are first built-in phase, runtime phase, and cleanup phase. Okay, so built-in phase means that I told you know. So this is used for configure and construct the test benches. Okay, runtime phase means for the time-consuming test bench activity like running the test cases. Cleanup phases means collect and report the resulting simulation. Okay, these are the main categories of UVM phases. Okay, so each test bench component is derived from the UVM component no, that define the phases. They are represented by callback methods. Hence, user may implement callback. Okay, that this I already told. Next, see here. First, these are the types of phases. Okay, so types of phases if you take. So here, what is this first this one is function, and what is this build phase. Okay, so how it is created, this is build or create the test bench component, and this is top down approach. This is nothing but top down approach. Okay, so we'll see the build phase, how the program will look like. So I wrote the program for build phase. So this is phase one. Okay, you see this one code. So So here I wrote the header files. Tick include. So these are the header files for the UVM, and class driver extends UVM underscore driver. So first what I am doing, I am writing for the first I am writing for what test. So that means first driver, after that environment, after that test. Okay, there is a sequence. First I am writing for driver. So class driver extends UVM underscore driver, and I need to create an ID now by using UVM factory. I'm using tick UVM underscore component utils driver. Okay, and next I am writing the for the function new string name equal to driver UVM component parent. Okay, super dot new name dot parent and end function and end class. Okay, so this I wrote the class for what driver. After that I need to write the class for the agent. Okay, so agent, how I'm writing class agent. So extends UVM agent. Okay, so extends agent UVM agent. Okay, this is agent, not agent class agent extends UVM agent. Okay, UVM agent. So after that I'm creating an ID, and I'm creating the handle like a driver drvh, and I'm creating the function new string name equal to the agent UVM underscore component parent super dot new and end function. Okay, and function voids face UVM underscore face. Okay, so this function also I'm writing, and after that I'm writing the function for what environment. Okay, environment. Okay, so class environment extend UVM underscore environment, and UVM underscore component utils environment, agent th I'm creating, and after that function new string environment UVM underscore component parent super dot new name parent. So I'm writing for the function. Okay, so everything is interrelated. Okay, everything is interrelated, and so after that, I am writing for the test at the last. Okay. So test at the last class test extends UVM underscore test, UVM underscore component details test environment. So I'm creating environment this one, and end function. Okay. So that means if I execute this program, just I will execute this, and I will see here. Just copy this, just paste in the ED playground. Yeah, what I will get, we'll see. 1 second, errors. Okay, okay. 1 second. UVM phase 2, if I see, UVM phase 2, this is, yeah, test I not wrote. Okay, 1 second. I'll execute this. Yeah. This is UVM phases. Okay, UVM phases is nothing but what? UVM function is nothing but it is top-down approach. First, you have test will be executed. After that, environment will be executed. After that, agent will be executed. After that, driver will be executed. And if you see the connection phases, connect phases, so how it will be executed? So it will be bottom-up approach. This is nothing but connect different test bench components using TLM port mechanism. This TLM port mechanism I will tell you in the coming classes. So just remember this TLM port mechanism. So this is bottom up approach. Okay. So here I wrote phase 2. So phase 2 means bottom up approach. Just you see, I wrote the header file and I wrote the driver class component. Okay, component driver class component need to connect. Okay, so for driver class, I created the class. Okay, this is for driver class and connect the phase typically prints in the component show hierarchy connection. Okay, so this is I'm connecting. So I'm connecting the connect the phase called in the driver. Okay, I'm connecting the driver class. After that, I created the agent class. Okay, agent class contains the driver. So you have a driver class, bottom up approach. Okay, first below there is a driver class, and above that there is a agent class. For agent class also you need to write the program. Okay, so class agent extends UVM underscore agent. I need to create the ID. Okay, driver DVRH, and next I need to write the function. Okay, and I need to instantiate the component. No? So component how I am instantiating DVRH equal to driver scope resolution operator type ID create DVRH this. Okay, I want to display this. Okay, display the agent. Okay, dollar display built face called in agent get full name. Okay, after that first driver class, next first driver, next environment, in SV driver agent. After that, I need to write for the environment. Okay, so here where I write, so I need to write for the environment class. Okay, so this is the class for what environment. Okay, so I wrote the class for environment and I am instantiated the agent. Okay, so that means every time, so environment will instantiate the agent. No, so agent will instantiate the driver. Okay. So for instantiating, what I need to do, agent th equal to agent type ID create agent th this. Okay. And void connect face UVM face. So I'm using connect face. Okay. Here I'm using the void function connect face UVM underscore face. Okay. So this is connect face called new. Okay. And after the environment, so you need to instantiate this test. Okay, test. So test means what? So I need to write for class for the test extends UVM underscore extends, and I need to create the environment, and I'm creating environment variable in envh, and here I'm writing the function, and I need to instantiate the environment. Okay, how I'm instantiating? So envh equal to env type id create envh. Okay, so after that what I need to do, I need to connect the face. Okay, bottom up approach. Okay, connect the face in the test. Okay, after that I'm writing the top module. In the top module what I am doing means module top initial begin. So I need to start the UVM test bench execution flow. So how it should be executed from bottom to top? First, it should execute where it should execute first driver. After that, it should execute agent. Next, you need to execute environment. Next, you need to execute test. That is nothing but bottom up approach. So in order to connect all these phases, you need to use this top module. Okay, so that means run underscore test in the double quotes. If you write test and end module, then all will be connected. Okay, so this program I executed. Okay, so when I executed, you see here first build phase called test. Okay, test is executed. After that, build phase called environment, and build phase called agent, and build phase called driver. Okay, after that, so build phase called agent. Okay, so that means test environment agent. So this is what test environment agent is nothing but bottom top down approach. After that, in the connector connection, this is nothing but build phase. Okay, I told you, no, build phase is nothing but top down approach. Normally first build phase is executing. After that, in the connect and connection phase, connect phase is nothing but bottom up approach. First, driver is calling. Connect phase called driver, and connect phase called agent, connect phase called environment, and connect phase called test. Okay, so this is nothing but what bottom up approach. Build phase is nothing but top down approach, and connect phase is nothing but bottom up approach. Okay, so like this, you need to connect all the components by using in the top module. You need to write run underscore test and in double quotes test. This starts the test UVM test bench execution flow. Okay, so that means you need to connect all the components, no? So you need to connect all the components by using what phases, UVM phases. Okay, and next you have what function end underscore of end of elaboration phase. Okay, end of elaboration phase is nothing but what before simulation starts. This phase is either to make any final adjustments to the structure, configuration, or connectivity of the test bench. It is also displays UVM topology. So before simulation, it will do some adjustments. Okay, so that is nothing but end underscore end of elaboration phase. Okay, this is also bottom up approach. Okay, so this is also bottom up approach. Okay, built-in, so I told built-in phases, built phase, connect phase, and end elaborate phases. Okay, to construct a test bench, it is necessary to build the component object first. You need to build the component object first, then connect from the hierarchy. Okay, so that means it consists of different types of phases. Build phase is top down approach, and these two are bottom up approach. Okay, uh, so if you see the this also I wrote. One second, this is in open state. One second, I'll close this. Which one? This one. Yeah, see here. This is what. This is third one. This is third one. Okay. So what is my third one? End of elaboration phase. Okay, end of elaboration phase, what it will do, any adjustments in the structure or configuration or connectivity of the test bench, it will do the end of elaboration phase. Okay, so if you see the end of elaboration phase, first I wrote the driver class. Okay, so class driver extends UVM underscore driver. Okay, and I'm creating the ID by using UVM factory by using the macros, and I'm writing the function new string equal to driver and the super dot new name parent and end function, and function void end of a, so I'm using this function. See, this is nothing but this one. So function void end of elaborate phase UVM underscore phase. Okay, super dot end of elaborate phase and dollar display. So end of elaborate phase called driver. Okay, get full name. Okay, so this is for what I'm writing for the driver class. Okay, next I need to write for the agent class. Okay, so agent class means what? I need to create class agent extends UVM underscore agent, and I need to create the ID by using macros UVM underscore component utils underscore agent driver dvrh. So I need to create a function for driver. Okay, so after that I need to create the function for built-in phase. Okay, so dvrh equal to, so I need to instantiate driver type id create dvrh this. Okay, and similarly, I need to use for this end of elaborate. So for an environment also, I need to write the program, same program. Means I need to create the class environment extends UVM underscore environment. I need to create the ID and I need to create the function, and then I need to create end of function on those things. And test class also I need to write. Okay, test class also I need to write same thing. Okay, and so after writing, so this is end of elaborate called test. Okay, for test also I need to write the function. I need to write the end of elaborate function, and after that in the top module what I need to do, module top. So I need to connect all these phases. No, so module top initial begin run underscore test end module. Okay, by using run underscore test I can connect all these components. Okay, so just this one I'm copying. Second. Yeah, this one I'm copying this. I'm pasting in the EDA playground. Run this. This is my last phase. Okay, build phase, connect phase, and next one is this is end of elaborate phase. End of elaborate phase. Okay, so if you see in this, yeah, see here first, uh, so see here first end of elaborate phase called driver and end of elaborate called agent. End of elaborate phase called. So this is bottom up approach. No, first driver is called. See here, end of elaborate called driver and end of elaborate called agent and end of elaborate called environment. Okay, so like this you need to connect all the components. Okay, so there are three types of phases. This is very important topic. So build phase, connect phase, and end of elaborate phase. Okay. Build phase create the test bench components. This is top-down approach. Connect phase connect the different test bench components by using TLM port mechanism. This I will tell you. This is bottom-up approach. And end of elaborate phase means what it will do. Before simulation start, this phase used to make any final adjustments of the structure or configuration or connectivity of test bench. It also display the UVM topology. This is also bottom-up approach. Okay. So this is about today's session. We discussed about the pack and unpack, and we discussed about the different phases in the UVM. Okay, yes.